Hi everyone, we're continuing with applications of circles right now. So again, we're going to use the equation of a circle and the distance formula to help us out. So we're working with example number 2, and this should be displayed on your screen in a text box coming up shortly. But let me read it aloud for you right now. Example number 2. Prove if the point 11, negative 3 lies inside, outside, or on the circle with the center at 5, 1 and a radius of 7. So we're going to start this off like we did our other application of circles. We're going to draw what we have. So let me do that first by having a coordinate grid right here. Okay, I want to plot my center, which is said is at 5, 1. So 1, 2, 3, 4, 5, up 1. That's my center. Then it says it has a radius of 7. So I can go ahead and put a dot 7 out to the right, 7 up, 7 down, 7 to the left. So I'll do that now. So I have 5, 6, 7, 8, 9, 4, 5, 6, 7. And then I go up 7. 1, 2, 3, 4, 5, 6, 7. Down 7. 1, 2, 3, 4, 5, 6, 7. And to the left 7. I can connect them to form my circle. And again, not the best circle because I don't have graph paper. If you have graph paper, use that. So we just plotted the center at 5, 1, and it has a radius of 7. We now want to plot the point 11, negative 3. So we're at 5, 6, 7, 8, 9, 10, 11, down 3, 1, 2, 3. This is our point. Okay. The question is, prove that this point right here lies inside the circle, outside the circle, or on the circle. We are human and we make mistakes. This circle that I drew, I know it's not perfect. So although it looks to be on the circle, I have to prove it using math that it is or is not on the circle. To do that, think about it like a bomb going off. Here's where the bomb is sitting, at the center. The bomb's explosion is going to carry us 7 miles out. So if you're in that 7-mile range, it's not going to be pretty for you. You want to be outside that 7-mile range to survive. So you want to be out here somewhere. We're at this point, 11, negative 3. How do we determine if we're inside that blast radius or outside? Well, let's just find the distance from the center to where we're at. The center point is at 5, 1. We are at 11, negative 3. Let's find the distance and see if we're within that 7 range or not. So find the distance between those 2 points. Well, to begin, let's write down our distance formula. D equals the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay? The distance then is the square root of 5 minus 11 squared plus 1 minus negative 3 squared. Simplify this out. 5 minus 11 is negative 6. 1 minus a negative is the same thing as a plus. So this is 1 plus 3, which is 4 squared. Square it, that is. Negative 6 squared is 36 plus 4 squared, which is 16. Simplify that, and you're going to come out with 52. So what is 52? 52 is this distance from the center until we're standing that point. The square root of 52. Well, what's that as a decimal? I know that the square root of 64 is 8, and I know that the square root of 49 is 7. Well, this square root of 52 is somewhere in between there. So the square root of 52 must be 7 point something. Well, the blast radius is going to carry us out 7 miles. And we are standing the square root of 52, so 7 point something. 7 point, I'm putting question marks right here because I don't know what it is. But I know that it's more than 7, so we're safe. So back to the question. Prove that the point 11 comma negative 3 lies inside the circle, outside the circle, or on the circle. Well, our number is greater than 7, so it's outside. So I would say point 11 comma negative 3 lies outside circle. And you can go on to say why. You can say the radius is 7 and we're 7 point something away from the center. And that's all you have to do. What were our steps to do this? Let's write them out right in here. What were our steps? Number 1, we drew our center and our circle. So draw center and circle. That's right here. That's the picture. And we drew our point, didn't we? So I'm going to draw and point. Number 2, we found our distance from the center and to the point. So distance. And then finally, step number 3, we compared our distance to the circle's radius. So compare. And then we were able to say inside, outside, or on the circle.